Welcome to Circuit Masterclass, your go-to channel for everything in power systems, transmission, and distribution engineering. Whether you are a student, engineer, or enthusiast, you're in the right place to power up your knowledge. Don't forget to check out circuitmasterclass.com for in-depth blogs and bonus content. We have given the link of the website below in the description. Let's get started.
What are the different protection schemes used in shunt capacitor banks? Normally, a double-star ungrounded neutral capacitor bank with series parallel capacitor units is used in substations. Before going into the protection scheme of the double-star ungrounded three-phase capacitor bank, we need to recall the connection configuration of the double-star ungrounded capacitor bank. Say this is a 10 megavolt ampere reactive rated capacitor bank. Here, we connect two units is series. This is a string of two series connected capacitor units. Another string is also of two series connected capacitor units. These two strings are connected in parallel to form a group. By connecting three such groups, one star of the capacitor bank is formed in the three-phase system. Now, there will be another similar star connection of the same identical capacitor units in same manner. The star point of these two stars will be connected via a neutral CT. Say this is one phase of a single star, this is R phase, this is another phase, the Y phase, and this is the B phase of that star. Similarly, this is the R phase of the other star, the Y phase of the other star, and the B phase of the other star. The star point of these two stars will be connected via a CT. This CT is called a neutral NCT. If any capacitor element of a string of a star gets fused, the capacitance value of this string will be reduced. Since the capacitance of that fused element is eliminated from the circuit, the overall voltage of this string will increase. Due to this increased voltage, the voltage balance between the two star points will be disturbed. So there will be an unbalanced current flowing through the neutral CT. And the relay connected to that neutral CT called the unbalanced relay will actuate either an alarm or a trip signal. We should remember that if only a single capacitor element of a single unit gets fused, then there will be a slight increase in voltage across the string. Because of that, the capacitor protection scheme should not actuate a tripping signal. The reduction in this small amount of capacitance does not affect the overall performance of the capacitor bank, so it should not trip. There should be a threshold voltage value, beyond which only the trip signal gets actuated. Below that, only an alarm is generated. As a general rule, an alarm signal is initiated by the unbalanced relay when the overvoltage remains under 10% of the rated voltage. Even though there may be a voltage increase in the string due to capacitor element failure, if it is still under 10% of the permitted voltage of the capacitor bank, then only an alarm should be issued, not tripping. But when there are many elements or units get fused that overvoltage crosses the 10% limit, the relay will initiate a tripping signal. By tripping the circuit breaker, it will isolate the capacitor bank instantaneously from the system. This is the typical protection used for ungrounded double-star three-phase capacitor banks. The second protection scheme used for capacitor banks is overvoltage and undervoltage protection. Normally, the overvoltage and undervoltage relays associated with the capacitor bank are fed from the bus PTs. If the voltage of the capacitor bank crosses the upper threshold limit, the overvoltage protection will be actuated, and the capacitor bank will be isolated from the system by operating the associated circuit breaker. Similarly, if the voltage dips or reduces below the predetermined threshold value, the undervoltage relay will be actuated to trip the capacitor bank from the rest of the system. There is a time delay provided in both overvoltage and undervoltage relays to avoid any maltripping due to transient voltage fluctuation. Overcurrent and earth fault protection are also provided to the capacitor bank. Here, normal line-side current transformers associated with the capacitor bank feed the overcurrent and earth fault relay. In the events of overcurrent or earth fault, These relays will trip the circuit breaker to isolate the capacitor bank from the rest of the system. These are the main types of protection used in 33 kilovolt capacitor banks. 1. Unbalanced current protection through the neutral CT. 2. Undervoltage and overvoltage protection. 3rd, general overcurrent and earth fault protection.
If you found this helpful, don't forget to like, subscribe, and tap the notification bell so you never miss a voltage boost from our channel. Got questions or want us to cover a specific topic? Drop it in the comments. We read everyone. Thanks for watching. And as always, stay grounded, stay curious, and keep engineering your future. See you in the next one.